Alright, welcome back guys. Today we're in 12.6 discussing congruence in right triangles, and it is very important to start off talking about you cannot use side-side angle to prove congruence, and I'm going to show you why right here. So I have two triangles here that have two sides that are the same. We have a length of 4 and a length of 5, and then angles that are the same, these 45 degrees. Now this angle is a non-included angle, so it's not between the sides. Notice we have my side, then my angle, my side, then my angle. These triangles are not the same, obviously not the same. I could make it a couple different ways and show that this doesn't work, but there is your proof that does not happen. So if we're going to discuss right triangles, it is important to know your terminology for right triangles. So the right angle is always the angle that is under the hypotenuse or across from the hypotenuse. They say it points to, you can kind of draw the right angle and think of it as an arrow. But my hypotenuse is always the longest side of the triangle, and the two sides that are left, the two sides that make up the right angle, those are both called my legs. So now we have theorem 23 here is our hypotenuse leg theorem, and it actually states that if the hypotenuse and leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then these triangles are congruent. Now what you might be thinking is, well, wait a minute, this is that side-side angle that I just told you you can't use. Now remember, these sides, a side relates to the angle across from it. So when I know that these two sides are the same, I know that these angles are the same. And when I know that the two sides and two angles are the same, then I already have congruent triangles, so then I can prove from there using CP/CTC that these triangles are congruent. Now, conditions for the hypotenuse leg, all of these have to be met. So we have to have two right triangles. Right is very important because that gives us the right angle and tells us about the relationship between the hypotenuse and the legs. The triangles have to have congruent hypotenuses, and there has to be a pair of congruent legs. So here's my proof of theorem 23. I have two right triangles here, and I have congruent legs, congruent hypotenuses, and I know they're right triangles, so I have that congruent angle. Now essentially what I'm doing is taking PQR and flipping it around. So think of R as going to S now, because I can put these two congruent legs against each other, and we know that this will be congruent to itself by the reflexive property. Then I extend X out to S so that it's the same distance as XZ, so I know that these are congruent. And if these two lines are congruent and meet the same baseline, that tells me that these two angles at the top here at X will have to be congruent. And from there, I now have side, angle, side congruence. That is just one way to approach it. Here is the other. Please make sure you've worked through the first part of the lesson and then come back and join us when you think you have the answer for the got it. So go ahead and solve it while the video is paused and then come back. So what we want to start thinking about is, what do we need to use the hypotenuse leg theorem? Well, we need to know that we have two right triangles. I have right triangles here, and I'm told that we have right triangles. We have two congruent hypotenuses, because remember, the sides that make up the right angle, those are my legs. And then I have a shared side here, so that is my congruent leg. So it satisfies everything we need for the hypotenuse leg theorem. Read through B and make sure it makes sense. This statement right here, it does not matter which leg in the first triangle is congruent to which leg in the second, is totally correct, because remember, we can manipulate our triangles. We're in three-dimensional space. I can rotate, I can reflect, I can translate, I can do whatever I want, so I would be able to match up. And we do meet the conditions for the hypotenuse leg theorem, abbreviated here, so my triangles would be congruent. We want to practice writing our flow proof here, so all you need to do is give the justifications for why we know these different steps. Pause the video and come back when you think you have all of the correct reasons put into this proof. So in A here, we see that we are trying to prove that these angles are right angles, and this line drops down to my straight line ST here, and since I see that they're congruent, we know they're congruent and supplementary, so they must be right angles. Since I then know that those angles are right angles, I then know that my triangles are right triangles, so that's just definition of the right triangle. Part C was given to us. Part D utilizes our reflexive property, just saying a line is going to be congruent to itself. And then because of all of this put together, we can prove based on the hypotenuse leg theorem that our triangles are congruent. So now do the same thing here to complete the paragraph proof. So what we first do here is say that our two triangles that we see inside this quadrilateral must be right triangles because I have a right angle down here and a right angle up here. So that's just by the definition of right triangles. Then by the reflexive property, we have BE equal to EB because it's the same line. Then I utilize one of my given properties that AB is congruent to DE, and those lines are right here. And then because I have the hypotenuses equal to each other, a leg equal to each other, and they are right triangles, I can utilize my hypotenuse leg theorem and prove these triangles to be congruent. Try number 3, even if you do not write out the whole proof, make sure you understand how we can utilize the hypotenuse leg theorem here to prove these two triangles congruent. All right, the most important part here in the given, I believe, is that I is the midpoint of HV. So that actually tells me I highlighted the wrong thing. So because I is the midpoint, by definition of the midpoint, that would then tell me that HI is congruent to IV. Both of those are legs of right triangles since I know that these lines meet perpendicularly. So all of that comes together to be able to tell me that I can use the hypotenuse leg theorem to prove these triangles congruent. Go ahead and think through how we would solve number 4. Very similarly to number 3, we know that M is the midpoint of TJ, which makes those legs congruent to each other. I've already got congruent hypotenuses. Since I see right triangles, they must be congruent. All right, go ahead, pause the video and try 5, 6, 7, and 8. Don't come back until you have all of them solved or until you get totally stumped. All right, I've got 5 and 6 solved out here for you. My hypotenuses, or hypotenusae, are highlighted in yellow on both. Then I've got my right angles indicated here in purple and my congruent legs indicated in blue. So in 5, we know that yes, these are congruent. The hypotenuse leg theorem tells me that. The one unknown thing in 6 is what is this angle, angle LMP. And because that angle is vertical to the right angle, we know that it also must be vertical, and therefore my triangles are congruent. Don't fall into the trap on number 7. We have congruent hypotenuses, congruent legs, but what we don't have is any information about the angles. So since we have no angle information, these triangles are not able to be proven congruent. And in number 8, I have two right triangles up against each other. I see the right angles here at X and T, which actually makes my RV the hypotenuse for both triangles, so we know that those will be congruent by the reflexive property. And RT is shown to be congruent to RX, which then lets us use the hypotenuse leg theorem to state the triangles are congruent. That is all that I have for you guys today on this lesson. So please make sure you've worked through the lesson, the practice work, and then let me know if you have any questions, comments, or concerns about this material. Other than that, I'll see you guys in class. Have a great day.